Till this point, what we have discussed is device to device communication. Okay, that based on the IP address or any of the physical address which is attached to the device. Now, on one device, multiple processes or applications are running. On the other device, multiple processes and applications are running. So, how process to process communication takes place? Okay, that from this point onwards, what we are dealing with process to process communication, because when you are accessing the internet, what you can see is multiple sites are open. You are doing FTP, you are doing telnet, you are doing HTTP on one machine at the same time on the other side also this. So how this is possible? Okay, how this is possible? So on the same IP address, which is single one, how I can have multiple processes running and that can be tapped with the other machine. So here two important concepts are there. Another is client server communication. Okay. So can you describe what is the server, or looking at any of the machine physically, can you identify that whether this is client or server? Is it possible to identify the machine whether it is server machine or client machine? So if I draw a figure, just I will share the things and then. So if I say that communication is happening between these two machines, okay, machine one and another, I will draw it in the bigger size, machine two. And communication is going on between these two machines. Okay, this is one, this is two. Okay, so whether this is client or this is client defines what particular thing. Looking at simply hardware, whether you can able to identify that whether this is server or this is client. Okay. Or one laptop is connected to the desktop. So looking at physical hardware, it is not possible to define this. That's why we have to study all these things which are now we are going to discuss, which is process to process communication. Before that, can you name the servers? Just put in the chat box what server names you know. I'll give example, something called as mail server. Like that, what are the other servers? Because that further defines the architecture of the system. But at least you can, if you can able to name the servers for any organization, how many servers are required, okay, and what are the different things in that particular server. Can you name the servers? Just as a mail server, like that. Mail server, Just put in the chat box names that you know. Web server, web server, database server, application server, transaction server, FTP's file server, token server. So if you name that, these are many. Okay, around 20 to 25 names you can take. But what you can see is FTP server, telnet server, mail server, database server. All these are the applications. Okay, so typical applications are running on these particular machines, and from the client we'll hook to that particular application. So at the transport layer, the address is port address. So from this point, for connecting machine 1 to machine 2, what we need is IP plus port together, so that it will hook to the particular process. So what I can say is, on this machine, different processes are running, different applications are running. Okay, so from the client, I need which particular application, whether this application or this application or this application, and that defined by the port address. So starting and stopping the services make the sense. Okay, so on one machine, FTP service is enabled. So immediately you can say that server is a file server, because you can able to transfer the file. Okay, if I enable the port 23, it is called as telnet server. From remotely, I can able to log into that particular server. Okay, like that, port 53 is DNS server. Like the different ports are defining different applications, and if that port is open, we call that machine as a server machine. There's no other difference. So at any point of time, your any machine, you can convert it as a server machine by simply opening and closing the ports. Okay, and that is very much flexible in the Linux. Okay, it is somewhat tedious in the Windows, but very flexible in the Linux. Okay, that's why most of the time Linux, you can able to configure anything what is required. Okay, anything what is required, and for that these transport protocols are supporting. So whenever you are defining IP plus port together, the name for that, we call it as a socket. Okay, we call it as a socket. So that entity is there. So whenever you want to carry out this, we call this as a socket programming. Okay, from one machine to the other machine, you are using socket, and through the socket, nothing happens. Okay. So when describing the socket, there are two types. I think we have already discussed. One is called as FDS. Full descriptor socket. Full descriptor socket means what? From one machine, what is required for the socket is IP address plus port address. Together is defined. At the same time, from the other machine, port and IP is defined. So when I'm defining all the things, that is called as full descriptor socket. I am giving complete description of my socket. Okay, so it is called as source destination, client server, machine 1, machine 2, whatever defines. But what I am defining the IP of this machine, port of this machine, which get connected to port of this machine plus IP of this machine. In some of the cases, it is not really required to define the entire thing. In that case, it is called as HDS, half descriptor socket. One is called as full descriptor socket. Today I have not taken the board, that's why somewhat tedious. But if full descriptor socket is everything is defined, half descriptor socket is not defined. Okay. So many times when you are accessing the URL, okay, what you are using is, so what I will do, I will take the white screen. So what you are giving is IP address, so that what 192 plus 168, sorry, 1.8, and after that what you are writing is colon some number 8090. So what this number is? So if I give this URL, I am getting site 1. If I am giving complete URL, I am getting site 2. Okay, here what is visible is different. Here what I visible is different. This is what? So with the IP address, I am writing colon some number. With the IP address, I am writing colon plus some number. And that number is, anybody? Anybody? That number is port number, yes. That number is port number, means user is having complete flexibility to start and stop the services from any of the port. Okay, so that it is user defined. It is user defined. But there are some well-known services are running on the particular port. So whenever I'm giving HTTP some IP address and immediately I'm getting site, means definitely that is running on the well-defined or predefined port, which is 80, because default HTTP service is running on the port 80. Okay, but here I'm describing with IP address colon something, means that particular service is running on this particular port. Clear? Okay. Got the idea? Because this is very interesting and important. Okay, so user is having complete flexibility to start and stop the services on typical port. So suppose I want to distribute some of the material which is there, and I want to put it on the website. Okay, so that you can able to see or download or whatever you want to do. But if I start that service on the default port, anybody can do that. But if I give some different number and that number is only known to you, that means when you are accessing this, you are aware of this number, so you can put that number and access the typical things. But outside people who is not doing, he can see only this part. He will not get the significance what particular things are running on this particular port. Okay, so that whatever required I can put it here, and remaining public I can put it here. Okay, I can put it here. So that default HTTP service is running on one particular thing. I can change the port and I can have other things in that particular part. Okay, so again, further it defines the architecture, because it is not possible for all the organization to put the different servers for the different processes. Means there is a separate web server, there is a separate application server, there is a separate data server, there is a separate transaction server, there is a separate authentication server. So unnecessarily this consumes a lot of hardware and this becomes problematic. So instead of that, what they are doing is they are keeping most of the things on the one machine, so that everything is served by the one machine. But again, that depends upon the number of users. Because from the first point, what we are discussing, the best application what I have observed on the is Indian Railway reservation part. Okay, very very finely running application so that transactions are happening. And what you can see is there is a Tatkal case, and if I open that at that particular point, how many number of users from the country are logged in, and everybody is accessing the different train and booking the particular spot. But you can see never duplicate ticket get issued or never duplicate seat get booked. Okay, so that kind of things are required, essentially required. So for that, whenever you are defining this for the hardware, you need to define what architecture you need, whether two-tier architecture, three-tier architecture, multi-tier architecture, or single-tier architecture. That depends upon what application you want to run. Okay, how many users are going to access this particular application, and what other things essentially required in that. Okay, that we'll discuss later when we go in the application module. But currently, architecture is again one of the important aspect while designing the web part. Why this web becomes widely popular? Because previously all the applications what you can see are client server applications, okay, where programming part is VB and Oracle, VB and SQL, like that. But today if I ask, you can say is Java, PHP, and number of other things. Okay, by the way, currently, do you know any of the typical architecture or methodology which is now widely becoming popular? Or if I say there are two things available at the outside, one is basic Visual Basic plus Oracle, and other is .NET. Which you prefer? Nowadays that becomes absolute, but still VB and Oracle is that way using the client server kind of thing. This is completely web based because all the things are stateless. Okay, what happens otherwise? If tomorrow railway reservation says that you have to download this application on your machine and then you have to run that, you have to make the client and then it will get connected, it becomes very complicated. Nobody will be going to use that particular part. But currently what happening is in your Explorer or what Google Chrome, just you are giving the URL and immediately you get connected. Okay, that is the basic difference. There is no constraint of any of the particular program running on your system. So only with the browser we can able to connect, and that is the power of web development. Okay, or you can say today's era. Okay, what .NET and other things you are looking. Anybody know this? This typically called as, now widely becoming popular architecture is called as LAMP architecture. Anybody knows what is this LAMP? Quick. Anybody? This is one of the architecture now becoming popular and popular. Most of the web development is now happening with these particular architectures. Anybody? Shivam? Shubham? Bhushan?
No, sir.
Okay. Yes, somebody has given Sanyogita. LAMP architecture is Linux, Apache, MySQL, and PHP. Okay. So what beauty is there? They are using Linux as a operating system, server operating system, Apache for web, MySQL, and PHP. The beauty is all these are open source. So cost of ownership is zero. Cost of ownership is zero. Means similar things are Windows and .NET with Oracle. Windows and .NET with Oracle. When I want to do that, I need to take the license, Windows Server license, okay, with the CAL. Okay, .NET is again not free. I need to pay the money. Oracle is again database, which is again I need to pay the money. And for .NET is for development platform. So all this together, my initial cost becomes more than 10 lakhs. Okay, so at the end, my project cost for these two is one is free open source, only development cost and other things. In the other case, where I'm using the Windows platform, my initial license cost is 10 lakh plus. So if I compare the two projects, the Windows project becomes costly. And this that way is licensing or ownership cost is zero. Okay, but still today if I see the market, the Windows.NET market is more than this particular part. Now it is shifting, paradigm is shifting, but still why this kind of parity is there, disparity is there? One is something called as free, okay, where I don't have to pay anything for the cost of ownership. And in the other case, I need all licensing where my cost becomes higher. And with that cost, I need to go for the further development. Okay, so if that development, if I call that costing is around 10 lakhs, then for first project, I can take 20 plus lakhs, and here project I can say 10 plus lakhs. Because here I don't have to pay anything for the license, and this becomes the architectural part. And for this, I think you have to study this particular software engineering in detail, which is again very interesting part. Okay, because this is called as life cycle management, software life cycle management, and there you can understand all these things together. But this is something called as architectural part where all web programming comes into the picture, and for that I need to understand completely regarding the sockets. Okay, where how I'll get connected to particular process and how I can take and write and read the data from that particular process. Okay, this is essentially we have to study. If time permits, we'll discuss this interesting part later. Currently, I don't want to waste the time in that, but it is very interesting that if these kind of multiple architectures are available in the market, still why one is popular, why another is not popular. Same thing what we have discussed it for the viruses, that if at all something is open source and everything, there is no virus threats for that, and something I'm buying completely proprietary things, and I have the attack, what we call it as a surface is more for the Windows. Whereas, because if I ask the question, one is a Linux server, one is a Windows server, which will get more attacked? Immediate answer is Windows server. But if I compare that, Linux is what open source and everything is available, some complete code is available, there nobody is attacking, and the Windows which is completely proprietary Atom, and their attacks are more. Why these things are happening? Okay, that you can understand with this particular TCP/IP and port concept. Okay, with the port concept. Clear? Because this is now becoming popular architecture. Okay, PHP is again good programming, SQL is for the database, and Linux and Apache combined together is for the web. Okay. Okay, now we'll back to our course so that you can understand these things later after completion of this. What you can see here is TCP/IP suite model, whereas bottom layer is this link layer, where what we have studied is data link layer, MAC addresses, and other things, and then studied IP with the ICMP, and IP is supported by ARP, RARP, ICMP, because IP is completely connectionless and unreliable services, so that all these protocols are supporting IP and everything. Now, if we move upward, immediately what you can see is there are two protocols. One is TCP, Transmission Control Protocol. Another is UDP, User Datagram Protocol. Okay. The name itself, that user datagram. Datagram is what? Datagram is again connectionless service. Okay, because all the datagrams are moving by its own way and reaching to the destination, whereas TCP is connection oriented service. Okay. And all these again by the different processes or applications. So it is completely in the flexible that whether you are going to use the service of TCP or whether you are going to use the service of UDP. Okay, that depends upon what application you want to develop. Okay, what application you want to develop. TCP is completely sophisticated connection oriented protocol. UDP is connectionless and other protocol. Okay, so both the things we have to discuss in detail, TCP and UDP. So last time what we have seen is structure is like this, hourglass structure kind of thing. Okay, whereas here multiple protocols are there, here multiple protocols are there. So IP is only supporting all these things. Okay, that we have discussed in the IP. Now, most of the devices are working at the data link layer and network layer. So here what you can see is device-device connection is there. Above transport layer, completely logical connections are there. Above transport layer, completely logical connections are there. So if we compare the conventional OSI model with the TCP IP model, here what you can see is application layer, presentation layer, session layer. Okay. So all this task is carried out by the application layer. Transport layer is this, and network layer is IP, and this is again data link and other. So till network layer, the devices are there. Which device is working at the network layer? Which device at the network layer? Router. Yes. That it will understand the logical addressing concept, and switch and other devices are at data link layer. So this works on the MAC address. This works on the MAC address. This works on the IP address. And the MAC and IP mapping is by ARP and RARP. Okay, MAC and IP mapping is by ARP and RARP. Okay, so that everything is working on this, so that which particular physical address, what logical address it is currently obtaining, that things are already clear. Now here what you can see is the comparison of these two protocols. One is UDP, User Datagram Protocol. Another is called as TCP, Transmission Control Protocol. Transmission Control Protocol. So it is datagram oriented, and datagram is completely connectionless. Okay, it is stream oriented. It is stream oriented. It is connectionless and unreliable service. It is connection oriented and reliable service. So whenever I say connection oriented, what is essentially required is I need to define the phase for connection establishment, phase for connection release. Okay, because I cannot make it half closed kind of thing. Whenever I need to establish the connection, there is a definite process which is called as handshaking process. Okay, at the same time, I need to define the process for release of connection. I need to define the process for release of connection. Okay. Once the connection is established, data transfer takes place, and as connection is already there, what you can achieve is sequential packet exchange. But in the UDP, as it is connectionless and unreliable, there is no guarantee that packets are reaching sequentially to the destination. Okay. Another interesting part is both the protocols are supported by the IP. Both the protocols are supported by IP. And what IP is, what we have discussed is IP is completely connectionless and unreliable protocol. Okay, IP is connectionless and unreliable protocol. So how we can say TCP is connection oriented and reliable? Okay, this is interesting. This is very interesting. Got the point? Both the protocol are taking the services of IP, and what we have studied in the IP is connectionless and unreliable. Okay, and here while looking at the difference for the UDP, I am saying that it is connectionless and unreliable. Okay, but for the TCP, what I am saying is connection oriented and reliable. Okay, so it will give me guarantee that packets will come sequentially and first it will establish the connection kind of thing. Okay, we'll see that. It is very interesting. Is it? Then UDP is supporting unicast and multicast. Okay, both the things, whereas TCP is supporting unicast only. Because it is a connection establishment, that's why it is one-to-one connection. UDP, I'm not establishing any connection prior to the communication. That's why I can able to have flexibility to carry out the multicast communication. Useful for few applications like multimedia application. Oh, this is again contradictory. Multimedia is what? Audio video kind of traffic. So what is essentially required in the audio video is sequential data, yes. And here what you can see is UDP, which is unreliable and connectionless, is supporting audio video. So last lecture what we have discussed is, if at all this is the audio video traffic, if at all this is packet reaching you first and this is then and this is then, and what is the use of this kind of traffic for the audio video? No. Then secondly, as there is no connection, there is no guarantee that packet will reach in equal interval. Delay. What this delay is called? What this delay is called? Anybody? These are the two kinds of traffic. One is this. So what you can see is this delay are completely different. These delays are completely different. Whereas here I can see somewhat equal delays. What is this called? Anybody? Delay, yes. This is called a jitter. This is called a jitters. Delay between the packets. And what essentially required for the audio video is regular jitter or controlled jitter. Otherwise, if this kind of traffic is coming on the screen, what you can see is completely jerky picture. But if delay is regular, what you can see is smooth picture. Okay, that's why in the multimedia it is very much essential to control the jitter, and that can be possible. Whether that can be possible with the not, but one of the Yes, that we'll discuss later. Okay, you're going ahead, Mansi. Okay, that we'll discuss later regarding the buffers and other part. But currently, still you can say how the UDP is supporting the multimedia. The reason is streaming. The reason is streaming. What is streaming? Streaming, data streaming. Because it is the main requirement for the multimedia, audio, video, and other. Currently, what the lecturing is going on is completely multimedia traffic, because you are watching something on the screen at the same time, your audio is there. So currently what happens when I am delivering this lecture from college, you are get connected from the home, somebody is connected with the lease line, somebody is connected with the mobile data, somebody is connected with the broadband, and I don't know, but somebody is connected with the dial-up. So everybody's speed is different. Somebody is connected with the 20 Mbps, somebody is connected with the 10 Mbps, somebody is connected with 2 Mbps. Okay, but still all the three are watching the lecture at the same time. And this very interesting is called as streaming. Got the point? The same video, somebody is watching with the high bandwidth, somebody is watching with the medium bandwidth, somebody is watching with the low bandwidth, but they are getting same video. Video in the sense multimedia. And this is the main task, and this is called as streaming. And for this, what is required is multicasting. And that is not supported by the TCP. That's why we have to take the help of UDP. That's why you have to take the help of UDP. Because same here is for all, with the different connection, with the different. Somebody is watching this on the mobile, somebody is watching this on desktop or laptop, somebody is watching this on the big screen, and whether somebody has projected or not, I don't know, but if at all somebody has projected this lecture, here what you can see is very big screen. So again, that is also different. That is also different, but all the people are getting same kind of feeling, and this is the beauty of streaming. This is the beauty of streaming. Got the idea? This is called as live streaming. In some cases, it is stored media, where when you are watching the lecture from the YouTube or any other stored video, then it is called as stored media. This is live media. But same case, streaming is required, because stored media, YouTube, you are watching on your mobile, you are watching on the laptop or desktop, and you are watching on the 70 mm screen. Okay, all the things are different. That we'll discuss in the multimedia traffic, but still, got the point? Clear? Okay, but here what at present what you can see is as multicasting is supported by the UDPTs using multimedia applications, and other protocols which we want to study is RIP, SNMP, DNS are taking the services of UDP, whereas HTTP, mail, telnet, all these are using the services of TCP. Means all these applications are connection oriented, these are not. Okay, these are not. What it is using is application to application communication. So what is required is multiplexing, because on one machine different applications are running, on the other machine different applications are running and connected with the same IP address, and it get hooked to the particular application based on the port address. Suppose I want this application, so any of the stream coming from this will get connected here. In some cases, it get connected here. In some cases, it get connected here. So at this point, multiplexing and demultiplexing takes place. Okay, because this will combine the stream and send it, and this will distribute it to the particular application. So both the TCP and UDP are using this very effectively, called as multiplexing and demultiplexing. That's why only multiple applications on the machines are get tapped. It is very much possible to tap that particular application.